Welcome to Locana Lounge. I'm Jen Campbell, and I support product growth and innovation here at Locana. I'm joined today by Brandon Razzo, Director of Design and Engineering Practice here at Locana. Today, we're going to talk about some of the challenges with traditional field execution and engineering design workflows and how you can leverage modern intelligent design to get increased efficiency and data accuracy with these workflows. This is a pretty hot topic in the market right now because, the traditional paper-based approaches to pre-construction survey, to CAD design, to as-built, the documentation that is generated from that, the output, is leading to poor quality data and an inability to rely on the system of record data. And not to mention that it's slow and inefficient. So this is creating a lot of urgency in the market, I would say, because there's a lot of demands on today's data sets. And, as we look towards the future of, these new tech trends we're seeing and kind of where the, AR and VR and artificial intelligence are at our fingertips. But the problem is that, the data issues, the inefficiencies, the paperworky stuff, it's getting in the way of allowing all of those new technologies to be adopted quickly and effectively. One of the things that we've identified is, traditional approaches, there is a disconnect between the way people execute their day-to-day work and the relationship that that work has with the system of record data. It just doesn't integrate well. It's cumbersome. What is the answer to this problem that we're seeing?
Hi, Jen. Thank you. Yeah, when you start looking at rapid growth and workforce retiring and all these new technologies, it's kind of where do we start before we get too far behind? And a lot of the problems are disconnects and silos within businesses, specifically utilities. It's kind of like the back office that's doing all this planning, and they want to make sure that the grid is reliable, and we've got these designers that are expanding the infrastructure, and then that that engineering package will say goes out to the field and it's constructed, right? But there's a lot of pieces that happen between all of that, and then on the back end, after it's constructed, really what is needed. I'll say at the back office, what is needed to rectify or you know iron out all the kinks in that data, and so you have some reliability in what is out there, how is it reacting, how can we do maintenance on it, all these
Mhm,
other
mhm.
things that you can utilize with all of that data that's being gathered.
Yeah, yeah. Thanks, Brandon. I think those are all the right questions and the right things to be asking because to me, it really does come down to the data and making sure that that foundation is strong. So I'm excited to chat with you more about today and get into that. But before we keep going, I wanted to just do a little quick intro on your background, my background, so everyone kind of knows who we are. Again, Jen Campbell. And I spent about a decade in GIS. I started my career at Esri, and so got to understand the culture, the way that people think, that live and breathe in the GIS world, as well as seeing the technology evolve over time. Then I spent about a decade doing ERP implementations, which gave me some great insights into the wide spectrum of business functions that can be handled with IT, and how in the best system situations you have a lot of as much integration as you can, and you try to just have all those different business functions interacting well with each other and doing the right communication and working with each transition really well. And one of the patterns again that I noticed in that space was how important it was that everything was working from the same base set of data, because if there was any kind of external data, it added so much headache. So that was one thing in the ERP world that we always were trying to strive for, is let's get that data centralized and have the data built in the day-to-day execution of work as much as possible. So and while in that space also, I got some exposure to field product builds, which kind of gave me that taste of what it is to be executing all kinds of work in the field and having a product to really support that. So of course, joining Locana was kind of my dream job because it was bringing all of those different worlds, perspectives, and technology exposure that I had into one place. And Locana, just in general, has such a passion for doing system integration the right way between GIS and business. And, in my case, loving the field and supporting a product that does that well here at Locana. So yeah, that's kind of my background and what drives me. But Brandon, please tell me a little bit about your background as well. I know you have so much great industry experience and you've seen a lot of these pain points firsthand, as well as gone through those transformation projects. So please share with audiences here what drives you and how that fuels what you're doing today.
Yeah, absolutely. And I'll start from the very beginning of getting into I'll say the engineering industry. When I was in the Navy, I was stationed in Everett Naval Station, the maintenance facility, which was totally not what I went into the Navy for, but where I ended up, right? So, um, and I got into CAD at that point because we had a lot of engineers, a lot of folks from on the Navy side that were the ships needed to be retrofitted. So they needed someone to learn CAD to help the engineers translate what the structural changes will be. So anyways, I assisted in that. And I literally was, I feel like the integration point because, I would help create these drawings and they were line symbols and whatnot to be printed out. We'd roll them up, we'd put them in containers and I'd walk them to the ship, right? And I would go through and see the red lines, right? I would help capture those red lines, so where penmanship and accuracy and all that kind of stuff from the changes that were made there, taking that all the way back to, the engineering and the materials and the how are we going to build this and the man hours and all of that stuff. So I was
Mhm.
actually doing the legwork there.
Oh, wow.
That yeah, that
That's
that
perfect.
turned into an opportunity at Puget Sound Energy up here in the Pacific Northwest in the Puget Sound area, um, where it's almost the same thing on the power generation side. So I went through that through transmission and then electric and gas distribution on the CAD side. And when I got into distribution is really where that CAD piece shook hands with the GIS piece. Right, meaning I could see full circle the life cycle of what was being created. It would go and be constructed, and then you needed to capture that data, and then that data was not only captured in the field but then it was brought to the back office, I'll say, to the GIS mapping, right? And so how do we record all of that? What part goes to billing? What part goes to your EAM, right, to order all of those materials? So yes, I've seen it all come all full circle. And got into leadership, which is where I'd love to see folks blossom, especially as all these technologies have started to shake
Totally.
hands.
Yeah.
Folks are starting to learn a little bit more on the engineering side as they are on engineering design, asset management, like your EAM and how software can really capture all of that. It can create so many efficiencies. It can reduce a lot of those rework things that we had to do and those questions, and
Oh, that's
breaking down the
awesome.
silos throughout the business. So, yeah, so that led me to expanding my boundaries, really, right? So, at the utility, we started some drone programs. We started to seeing the value in mobility and field capture, and I found myself a couple years ago wanting to expand that as I was talking to other utilities through demonstrations and whatnot. And it's
Mhm.
great. The utility industry is great because we share a lot of ideas, right? It's not like we're direct competitors, and we're all trying to do the right thing with reliability and doing the best things for our customers. So that led into me wanting to expand my horizons, and so I joined the Locana team here. We created a practice for utility design and engineering, so bringing all of what I learned to the GIS world, right? And really expanding that to field capture and really creating a workflow or a work stream that has some efficiencies to it, and then we can start doing those really cool stuff, 3D. We can start,
Yes.
doing BIM, and now that there's some intelligence behind it, and we've got some data accuracy, there's just so many different levels that the utility can utilize in that information to do all of the, risk analysis, all those other cool things that utilities do in their business. Just getting those efficiencies, and it's fun to see utilities come along for that ride.
Yeah. Thank you, Brandon. And I think that's an energizing part for me as well. Again, coming back to all the new technology features and thinking about how utilities can lean into that and really gain efficiencies and new intelligence, new ways of working, get safer, get more efficient, reduce risk with that new tech. But having that foundation is a starting point. And I know that, as we've chatted, I always love to just absorb your industry expertise. I always learn so much. And applying that, seeing how you apply that to doing designs and integrations the right way, and how really get jazzed about the products that support the right way of doing this stuff. Thinking about the products that by design are, again, helping to build and honor and leverage that system of record, being kind of that foundational point, right? And so I think that's one of the things you and I we connect on, is just doing it the right way, doing it in an intelligent way, and through that, what future benefits the utilities can achieve with that.
Absolutely.
If you could tell us maybe a little bit more about how that data is created and what those workflows look like in the traditional world.
Yeah, absolutely. And so I would say that, a lot of the requests for engineering or changes, infrastructure changes, come from many different, I guess, sources. It could be infrastructure planning. It could be reliability. It can be from new customer construction. It can be for maintenance. Right. There's a lot of different areas, but ultimately they all come from, or the engineering piece all comes from those needs. Right. And then you have to have a plan. Right. What's that plan look like? Where the utility that I came from was very AutoCAD based, and so whatever utility, I guess they need to make that plan and put it on paper, because how do you translate that to the field and what to
Mhm.
build and what to construct? So
Right.
typically you've got CAD, which was in the days of I'll just say 10, 20, 30 years ago. You've gone from someone plotting and actually drawing, creating drawings by hand, to CAD, to where there's vector data, but they're using a lot of symbology and line types and blocks and a lot of
Okay.
things that I wouldn't say are intelligent. You can definitely have attributes to them and they can be dynamic, right? Um, but ultimately you're printing something out, right? So you're losing a lot of
Mhm.
that data, and it's a translation of symbology, basically. That goes
Okay.
out into the field. That translation happens with the foreman, will say, or whoever's looking at the plans. They go and do their construction. Not Unfortunately, not everything is built as designed, right? So there's changes that happen out into the
Right.
field,
Right.
whatever that is. Maybe there's more or there's less. Or they're out in the field and the plans say, the infrastructure is on a certain side of the street, but it ends up, when you get out there, it's on the opposite side of the street. So there's kind of, am I looking the right thing? So there's a little bit of questioning, right, of what they're looking at. So
Right. Yeah.
construction happens, all the redlining is done, and you're susceptible there still to, it's being translated on paper. So it as simple as handwriting, is that an 8 or is that a B, kind of a thing, right? Is it a 2 or a 7, kind of? All
Yeah.
of that happens, and then that
Interesting.
has to get back to the office somehow, and then usually that drawing or that plan that's been redlined, and this is how it is in the field, goes two ways. It goes to billing, and then it goes to GIS so they can record it, right?
Yeah.
um, and so there can be a long time between being field complete and then that data getting into the back office, and then for someone else to see that information, right? So
Wow. Yeah.
leveraging GIS, right? Everybody at the utility should have visualization of that infrastructure and what that looks like. And we're in an on-demand world today. I mean, you can order anything from pretty much Amazon, and it'll be at your doorstep, depending on where you live, within 24 hours, right?
Uh-huh.
But
Yes.
these major construction projects, it can take, days, weeks, months, sometimes, depending on the size of the project and the priority of it. But um, that's kind of like I'll say what we're trying to transform, right?
Yeah.
And then how do you
Definitely.
gain some intelligence and leverage? Do I need to interject technology here, and what am I going to get out of it? And you
Yes.
said a
Yes.
big thing earlier. You said safety, reliability, and efficiencies, right? I would say that's what's just huge for utilities. Yeah.
Mm-hmm. Mm-hmm. Yes, thank you, Brandon. I appreciate that kind of painting the picture of what traditionally it has been the approach and where we see some technology solutions that can streamline this really well. Because you kind of mentioned you mentioned a lot of interpretation, right? And handshakes, paperwork, things that can take long because it like they're because of that interpretation, all those steps along the way. So what I would kind of summarize as what we've seen as business impacts from that inefficiency because of the paperwork and what sometimes we call data handshakes, or basically any time when information has to come out of the system to a piece of paper to interpreting, is that a 7 or a 2, that type of stuff all slows things down. It also brings uncertainty to the data
Mhm.
accuracy, so people start to feel a little bit nervous about relying on that data. It's there's so much manual work to do that paperwork input, so all of this just slower and uncertainties around the data, not to mention the fact that there's risks of delays, or possible inaccurate work execution because of this stuff, because of all that, interpretation that has to happen. So, from a roll up business perspective, the impacts are quite real. We're both here, Jazz, because we see there's a real theoretical answer to this that just by the way these things are designed, if they're designed right, the reliability, the speed, the accuracy is built into the process. It's built into the way that people work. And so that's why I think having the right tools makes such a difference. But before we dive into the specific tools that we're kind of thinking through, Brandon, I'd love if you could now, thanks again for painting that picture. Kind of what is that vision for the future? What kind of theoretical approaches should companies be thinking about in order to reach what I like to call or we've heard other leaders in the industry say modern intelligent design, and pairing that with a modern mobile mapping solution, which I've talked about a lot too. So when those two are come together, can you paint now the ideal workflow of how to do it with those modern approaches?
Absolutely, yeah. Starting at the very beginning of the process, when work has been decided it's going to do in this place, what is the starting point for that engineer or that designer? Um, a lot of times it's field validation, right? It's you can bring in survey data, you can get the data from the developer and whatnot, but then you always have to put eyes on that. And so, with the power of having GIS in your hand, I think is, where we are today and where utilities can strive to be. And that is being able to be in the field on location, see where your assets are within GIS. And if there are any conflicts, you can create a work order to have that changed, right? Or a map correction, we'll call it.
Yes.
Um, and with connectivity, you can, or even offline, right? Because what we like to call Lemur is our offline awesome tool. But being out in the field, it can be in a rural area or whatnot. But you get to see your GIS data, right? And you get to
Yes.
add to that, and then that can go to the back office so they can make the changes before construction actually happens. Um, so you do your field
Same.
validation, you take your notes, you take your pictures, right? And then you push those back electronically to GIS. And then you've got the designer, they have that information at their fingertips. So they can utilize that and bring that into their platform, their CAD platform, and they can, at that point, start their design. They can utilize GIS data because that's data they can bring into their CAD tool, and then they have the ability to do their design. And if you've got that connection to your EAM, so there's three pieces here: there's asset
Hmm.
management, there's
Hmm.
your design tool, and then there's your
Yes.
GIS, right? So
Right.
for those engineers and those designers, they can create the infrastructure that they want. They have takeoff points from where GIS is, and then as they're doing that, their bill of materials is being created. On the electric
Um,
side and gas side, there's the beauty about CAD is it can have some engineering tools in it, right? It's the reason why we have it, right? It's got precision. It's got the ability to, on the electric side, perhaps do, some analytics with guying, or excuse me, with like voltage drop, or it can do automatic things like guying, or, when you're setting this pole, it's not just a circle anymore. This pole actually has attributes. It's a, class one 35-foot cedar pole, whatnot. It's got the things that GIS wants, right? It also is utilizing the data coming from your asset management. So as you're placing these poles in your design, you've got a bill of materials that's being created. You've got basically some vector data that has some intelligence that you can pass to GIS as a pre-construction state. So even before it's built, there's a visual representation within GIS, right? So we're taking that,
It's amazing.
when I was talking earlier, when we're taking that, the plan goes out into the field, it's constructed, and then it takes time to get into GIS.
Right.
We're circumventing that, right, by giving it a status of pre-construction. And
Yes.
so there's a visual representation there. Now, even if there is paper, or what they're utilizing in the field, and we hope they're using some kind of field application, um, then that data goes back to GIS electronically, and now you're putting in your mapper in a situation where they can QA the data, and they can push that data to production versus having to remap it. So we're already getting some efficiencies
Amazing.
there. Yeah.
Yeah. That's pretty amazing, Brandon. I appreciate you kind of talking through that, because I, to me, when you step back, some of the common threads through that story is GIS data, EAM data, and the fact that instead of, these workers, these designers working kind of in silos within their apps of choice, or apps they've been trained on, or if you're talking field, they may not have been trained on any apps, but they're trained on execution. They're trained on construction or surveying, or validating things about the equipment that's out in the field. They're not trained on GIS. So the trick is getting the right tools that support those workers in their space, in their expertise area, but in a way that allows them to also be curating and working from the GIS and the EAM system as they execute. That's the trick. So how does this work in reality? And this really gets to the product combination that Locana collectively has identified, and you and I both get. It's such a privilege to work on the teams that are implementing these products. So Locana, yeah, you mentioned Lemur, right? Locana is Lemur's modern mobile mapping app that does just that. It brings the sophistication of GIS out to the field worker, but in a UI and a user interface that supports them to keep being experts in their field work, and they don't have to be experts in GIS to do their work. The tools are designed, the tools are focused on the particular workflow. So you had mentioned the field validation, and that's an example where they go do that work, but they're working in Lemur being a tool built on the ArcGIS platform. Again, gives them that simple UI that's tailored to field validation, tailored to the work they're doing, but that works with the GIS. And similarly, on the design side, with SBS's automated utility design, which we also know as AUD, it is a CAD-based tool. And the designers don't have to learn anything about GIS to just dive in and work with AUD on day one. At the same time, as you mentioned, AUD receives that GIS data as a foundation that's coming in from that field validation. So they have that context already in the system of record, which that tool imports and works with. Right. And so that then and then, as you mentioned too, as they're building their designs, it automatically creates that data. So, and here's where I'd like us to just maybe and we can tag team this a little bit, but through the Lemur plus AUD approach to solving this, what that flow collectively looks like. And we, I mentioned field validation. So from the Lemur side, what that really means is to your point, taking that data that's been collected by the surveyor, then going out and validating that everything's right, as well as identifying the existing assets that might be in the field and making sure those are right. And so if there's a GPS adjustment that's needed based on level of accuracy or whatever is needed, that can be incorporated into what you're doing with Lemur. And or if there's maybe like a data change, an attribute change with that particular asset that's identified, they can make it right then and there in Lemur. And then once they're done with that field validation, it goes back directly to the GIS system, which then is handed over to AUD. So tell us a little bit about, once all of that pre-work's done, what does the designer do with the AUD tool?
Right. Yeah. And I like to think of, the whole, if I was to think of it as from a linear value, right? You've got Lemur on the bookends, right? And what you were mentioning was at the very beginning of the process. There's so much value in being able to be, out in the field and capture easily, right? Because not, there's a lot of value in photos. There's a lot of other ways you can get like aerial imagery and whatnot, but you know, you're taking a photo of what you need to do your job. There's, with Lemur, there's forms. There's a lot of other applications that you're out in the field for too. Is where there's
That's
a
right.
lot of there's multi-purpose, right? Well, what I love about the map correction piece that you spoke about is that sometimes there tends to be at utilities, maybe some confidence, non-confidence in GIS or where the assets are because folks out in the
Mm-hmm.
field are accustomed to it, right? Now they can make that map correction out in the field and they can feel like they're actually contributing to the big picture, right? And I have found that
Totally.
so much value at the utility I was at is, folks, if they have the ability to send a map creation or a map correction and see it, a lot of times they would submit it and they wouldn't see it for some time. Now they can do that map
That's right.
correction,
That's right.
all right? And before they even start construction, the GIS data is accurate. So
It's
yeah,
amazing.
going to that level of accuracy, right, is curating or getting more accurate on the legacy data, and then also being able to capture with GPS. If your level of accuracy is changing, capturing that data as well, and then you pass that over to AUD. Now,
Brilliant.
inside of AUD, right? Inside of AUD, now you have your takeoff points. If it's replacements or it's new build, you have the ability to change the status. You're connected to your asset management. So as you're doing all of those, this is more than just CAD where it's line types and symbology. Now there's some attribution, right, going along
Mm-hmm.
with
Mm-hmm.
these assets, at this point. Now, what I love about it is this is for small jobs or big jobs. AUD is looks and feel a lot like AutoCAD, right? And it is the engine of AutoCAD that is driving it. But now you're modeled based instead of symbology based. And now, as I was saying, is a
Yeah.
pole, a certain class of a pole has certain attributes to it. Conductors, transformers, all of them have connectivity attributes that you would expect from a GIS, and even downstream that to like OMS or ADMS. AUD has the power to make sure that the data that you're passing up to GIS, has that connectivity, right? That piece there. So there's
Yes.
so many, I would say, engineering tools that we can configure within AUD to help you as a utility. Not only that, I mean, it can
Amazing.
be your construction standards, right? So
Mm-hmm. Mm-hmm.
not every utility has the same construction standards, but they all have good standards. So how do you apply that to your software versus back in the day of AutoCAD when you would do your design, but then have to check to make sure that that was within the standards. And so you'd open up the standard book and find the page, and sometimes you'd have to
Mm-hmm.
refer to that and whatnot. So
Mm-hmm.
there's a lot we can do within AUD to make that role a lot more
That's
efficient.
amazing. That's awesome. And then on the receiving end, once that design has happened, that data being built and within that modeling and then living in GIS, that becomes obviously GIS data that can fuel Lemur. So now when the construction is happening, it's really a matter of taking the design. Not, I mean, yeah, there may still be cases to do some printing out, but when it comes to actually recording what's going in the ground and knowing exactly where it is, having the right equipment to validate that the level of precision accuracy that's needed for the utility, also easily collecting attribution around that particular piece of equipment. So you can say like, I want this type of equipment in the ground, but when you get down to, okay, and I'm pulling something specific off the shelf, now there's a serial number, now there's traceability and everything in a product life cycle that has to come into play, but that is captured in the field as well digitally. And you
Mhm.
can use things like barcode scanning, and you kind of mentioned those, some of those form options, to capture all of that rich data in the field digitally as it's going in the ground, as it's being placed. And now it's not a matter of handing a piece of paper with a bunch of information back to someone in the back office. It's a matter of it just automatically gets recommitted back to the right systems of record, and now becomes an exercise of validation and committing that data to the system.
Yeah, exactly right. Yeah, and I'm not sure if we mentioned the intelligence piece of it, right? Just yet. But I'd like just to add, as you're basically building a model, and that intelligence is the characteristics of those assets, right? So, um, even adding some efficiencies to the design and engineering piece, right? Prior to that going to the field, and then
Yes,
hopefully that translate into less changes in the field, right?
yes,
But if there
yes.
are, you can easily capture those and then send those back so they can get into production GIS in a faster way.
Yeah, yeah, and I appreciate you mentioning that too, because yeah, again, model based within AUD, having that validation as the design's being built, that it's being built in a way that makes sense for the equipment used and for the resource that it's measuring or throughputting, right? And then when
Mhm.
you're out in the field, to your point, there are going to be fewer corrections. But if there is still a correction here and there, that is also captured digitally with digital redlining tools that, again, live within the systems of record, so they don't have to try and interpret a 7 or a 2. They know it because it's digitally typed in. That becomes the communication channel. This is the
Absolutely.
intelligence we're talking about. Yeah. Yep. So I just thinking about time here, I wanted to wrap up with just a couple other, fun sound bites with Lemur and AUD, because we're just both so jazzed about those products, what that kind of means for setting companies up for the future. So, we talked a little bit about Lemur. I'll start with Lemur. Lemur being really easy to use, having a specific set of data layers, tool sets just for the worker out in the field for that particular workflow they're executing. So that makes the UI really intuitive, really simple and tuned to what the user needs, and allows them to do their job out in the field. It's also offline native, which means that regardless of what happens connectivity wise, regardless of whether it's a surprise or not, you're fine. You can execute even if you go out of signal, because especially with new construction, there may not be cell infrastructure out there yet, but that's okay. You can still operate in the field the same exact way you would if you were online. So that's the beauty of having the offline first design that Lemur has. We mentioned it was built on top of the ArcGIS Esri technology. So all of that GIS is just built in. You mentioned, Brandon, and I love this, that workers become curators of the data, which in turn allows them to have a greater sense of reliability with that data, because they have control to influence if they find something wrong, or influence how it's created. So all of that really helps to drive that sense of ownership and
Mhm.
reliability that we're going after. So anything else that you want to highlight from the AUD side of coolness of the tool set?
I think, yeah, just stating that it's a modern intelligent design tool, and now we're giving the designer, I would say, not necessarily more tools, but smarter tools and ways to create efficiencies, where they can stay in one system. I think the bill of materials is huge. Being able to standardize, I think for utility, that's very important. Having those construction standards. Um,
Yes.
the enterprise cohesion, just basically, you're now getting everybody on, I would say, on the same mindset of how the data travels, right? And that data accuracy,
Right.
it's coming from, it's
Right.
created somewhere and it's going all the way across these different business units and these workflows. But ultimately, that system of record, needs to be that system of record, so you can query it and get accurate results.
Yes.
Um, as we're going down this road, it opens up the opportunity for 3D, right?
Right.
Capturing sensor data like LiDAR and utilizing that within AUD
Same.
platform as well. Just for like clearance's sake, as we're building these models in AUD, we're going from the traditional 2D paper view to maybe creating it like that, but now these models have a Z value, right, or a height to it. So that class one 35-foot pole, you hit the 3D button and it turns on its side and it shows you the spacing between the spans, the spacing between, elevations. If you're
Yes.
going from overhead to underground, it can show you those transitions, making sure that you're aligning your equipment right. There's things like
So
automated guying, so your pole doesn't fall over, that kind of stuff. So there's a lot of cool features that, now that we're starting to develop, um, these platforms in this workflow with more accuracy, then you can start doing those really cool things to get value from that data accuracy, right? Whether it's BIM or some augmented reality or even some virtual reality experiences. So all of that, I think once you get this baseline down, then you can start introducing a lot of these cool technologies, and understand that that data accuracy is core to being able to do these, I'll say tomorrow technologies or today to tomorrow technologies, right?
right.
Um, but they're useful because they're accurate as well, right?
Yes.
And
Yes.
you can put parts and pieces together, and so then with all of that
Definitely.
comes risk management, and just a
Yes.
better experience for the utility, and they're more efficient, and that turns into customer satisfaction, quite honestly.
Oh, yeah. Yeah, that's definitely a good point. Fundamentally, that's what it leads to. Yeah, and I think back to the reliability, the safety, the accuracy, and the efficiency that all of this generates. And I appreciate you mentioning those future technologies because I don't think we can understate how important it is for utilities to have accurate, efficient, reliable data as soon as possible
Mhm.
because these technologies are available today. And the wave is just going faster and putting more pressure on the expectation that fundamentally the data's right, the baseline workflows are right, and the new offerings of tech do lead to customer satisfaction. And it's starting to actually become a customer expectation that they are as safe as possible, they're getting the best possible service, and the path to that future and streamlining that future are the new technologies like augmented reality and AI. And the way to lay the foundation for that is what we've been talking about here this whole time, operating off of that system of record, building tool sets that curate that automatically, and having that be the baseline, having the intelligent tools that enable that. We don't have luxury anymore to do things the old fashioned way. So yes, these tools are the way of the future. It enables a path to the new tech and the new expectations for that customer base that we know is coming quicker than than is comfortable sometimes.
Oh yeah, and all of our utilities, they've got grid modernization initiatives, reducing
Yes.
carbon footprint and all of those fun things. So these are tools that definitely help them get there.
Yes, yes. That's great. Well, thank you so much for joining me today, Brandon. I know our collective teams are so passionate about both of these tools and the way that it enables our customers. We have collectively built some demos where these two tools can interact really well, and you can see it in action. So I wanted to just say that our teams will be at some of the upcoming conferences like Esri's IMGIS or Distributech. That will be at others as well. So feel free to reach out to us directly if you can't make those conferences. But that's where you can see a live demo of these two products in action. So please track us down there. We'd love to show you the benefits and give you a visual of how this works. And of course, please reach out anytime on LinkedIn or check us out at locana.co. On both of those channels, we'll be publishing more content, more details around Lemur, AUD, and those combined tool sets to give a complete end-to-end workflow solution. So thanks again for your time, and thank you for joining us.
Awesome. Thank you.